So here I am in the command prompt inside the SQLite 3 program looking at the shelter database. So using our .schema command, I can see that this is the create table statement used to create the pets table. Well, as it stands, this create table statement is a little bit problematic, and I'll explain why. So first, let's actually look at the information that's in our pets table right now. So to make it easier to read, I'm going to turn on the header, and then change the mode to column, and then select all the information from the pets table to print out. So you'll notice right now, we have 2 pets with IDs 1 and 2. Well, let's say a new cat named Binks, perhaps a breed of Bombay, was just dropped off at the shelter, and the attendant enters this information into the database. Did you notice if something was off? Well, let's take a look at this using the select statement to see in more detail what exactly went wrong. So looking at the output here, we notice that our supposedly unique IDs are no longer unique. Notice that both Tommy and Binks both have the ID 1. Alternatively, what if this scenario happened? Say an attendant forgot to enter the name of a cat completely. So for example, a cat enters the shelter, the attendant enters this information. So notice that the attendant completely forgot to enter the name of the cat. And so here we just see a blank space for this 4th object here. SQL has some of these easy keywords that we can add to the columns to help us avoid this. And note that these are just a small subset of all the attributes available to you. But these are going to be the important ones for us in this table. So ones I've listed here are the primary key, auto increment, not null, and default. So let's take a look at these at work. Let's see how they affect our headphones example from before. Now with our headphones, remember there were 5 attributes we want to store. So it's the name, the price, whether or not it was in stock, the description, and the style. So I've taken those 5 attributes and put them as the columns in this table, as well as included the ID column. Now to create our headphones table, we need to use this statement. So create table with the table name headphones, and here would be the columns: ID, which is an integer, name, which is text, price, which is an integer, style, which is an integer, in stock, that would be an integer, and lastly description, which will store as a text. Now let's see how we can use those keywords from before to help make our table more robust. So first off is the primary key. So this keyword marks the column used as a uniquely identified row. And like I said, this ensures uniqueness, meaning there can only be one primary key per table. So the primary key attribute is often used in conjunction with the auto increment keyword. And this keyword is used to make an ID column that is both unique and automatically picks up a new unique ID when you make that row. So this is how it would look in our headphones table. So I've added the keywords right after I declare the data type for the ID. So after integer here. So I've added primary key and auto increment. So note that I could have added one or the other just by itself, but in this case I decided I wanted to add both of the keywords. So having added those keywords, this means if I add 3 new headphones, inserting 3 rows, even if I don't add the ID, the table would automatically increment the ID without me specifying what the number would be. So for example, this one might get the ID 1, this headphone might get the ID 2, and this one might get the headphone ID 3. Now say I've added those 3 rows into the table using the auto-generate IDs 1, 2, and 3. What if I try to enter a new row with an ID that's already used? So in the example here, I'm inserting a headphone into the ID 1. Well, I would get this error. And this error tells me that I can't enter an ID that's already being used because it's not unique. So this here is an added layer of protection. So next up is the not null keyword. So this keyword allows us to say when a value is inserted into the table, it must have a value associated with it. So if, for example, we didn't want to allow a missing name from the table, we can change our creation statement to be this. So adding not null after the data type text indicates that the name value must have something associated with it. It can't be just null. So let's head over to the terminal and try out what this command looks like there. So let's use our .open store.db command and move over to our store database. So inside this database, I'm going to create a table where the ID is the primary key, and I want that ID to auto increment. And I also want the name value not to be null. So let's enter those specifications. Now if I enter a headphone that doesn't have a name, I should get an error. So let's try that out. And as expected, I'm getting this error that says not null constraint failed, headphones.name. And that's because I'd specified up here that I want the name not to be null. But when I inserted a headphone into it, I didn't have a name specified. And so the database is telling me, nope, you can't do that. Remember, you have to have a name. So finally, we have here our default keyword, which adds a default value if no other value is given. As it says here, when inserting a new row, if no value is defined, the default value given will be used. So say for example, if no value for in-stock is given, I want it to be set automatically to 0, meaning that there's no stock. Also, if I want in-stock to never be null, I'd add the not null keyword here. So this is what the entire create statement will look like. Notice that I don't add any commas between the keywords, just spaces. Alright, so here we are back in the command prompt, and let's see that default keyword in action here. So before I do that, I'm going to drop the table we just created in the previous example, so we start fresh. So drop table headphones, and just to make sure, yep, so no more tables inside this database. So from here, I want to create a new headphones table that involves our keyword default. So create headphones. So for our in-stock column here, I want to specify that it's an integer. I don't want it to be null. And I want to give it a default value of 0. Now, given these constraints, if I insert a new headphone again, but I don't specify whether or not it's in stock, the table should automatically set the headphone to default as 0, which corresponds with not in stock. So let's try that. So I'm going to insert a new headphone in, leaving off the in stock column. Alright, so that command should have inserted a new headphone into our table, and we can see that by using our select from command. So here's what the headphone looks like as a row inside our table. Notice there's a little bit of a wraparound for the description, but that's okay. So first off, we have the ID that we entered. Oh, actually, we didn't enter. Remember, we automatically incremented it here. And then we have the name of the headset, the price, the style that we specified, and then in stock. So look, it automatically used our default 0 here. And then our description, standard inner headphone color black. Now to make our create table even more robust, I'm going to drop this existing table and then create a new one where I add not null to the price as well as having nothing for the style. So here's what that would look like. So like I mentioned before, style won't have any constraints on it. But in stock, we'll have a couple of constraints on it. And the description will just be text. And there we have it. So this is the newly created headphones table with all these new constraints added to it.